Good morning, everyone. Today we're going to look at percentage composition and also at empirical formula. Now let's start with percentage composition. Now percentage is out of 100. And what you need to know is percentage composition is what mass out of 100. So let's look at our first example here. During photosynthesis, glucose is produced according to the following reaction. Now they give you the glucose over there, and when they ask us for percentage composition, they want to know what is the percentage of each of the elements in that compound. And remember, it's a mass percentage. So first, we're going to look at the mass of that total glucose. That gives me 72 grams of carbon, 12 grams of hydrogen, and 96 grams of oxygen, altogether giving you 180 grams per mole. Now for the percentage carbon, that's then going to be that 72 divided by 180, 72 out of the whole 180 times 100, and that gives you that 40%. And then the same for hydrogen and oxygen. And sometimes they ask you something like calculate the mass of carbon in 1 kilogram, and 1 kilogram, that is 1,000 grams. So you can either work down here in kilograms or in grams. If you put it in grams, then your answer will be grams. If you put it in kilograms, then your answer going to be kilograms. So here we chose to do grams, and therefore we end up with 400 grams, because that's 40 out of every 100, because it was a 40% carbon. The next question is an example from the 2015 matric paper. There they told you ammonia is used in the preparation of other fertilizers such as ammonium nitrate, and they ask us to calculate the mass of nitrogen in a 50 kilogram bag of pure ammonium fertilizer. So first we need to look at ammonium nitrate. What does the formula look like, and what is the mass of ammonium nitrate? So for ammonium nitrate, NH4NO3, right, you need to know your table of ions to write that. And then that tells you nitrogen, we've got 2 over there, so that will be 14 times 2. Hydrogen over there, 4 of them, 1 each, and then we've got 3 oxygen with 16 each. So altogether that gives you 80 grams. So for the percentage of nitrogen, we're going to say 28 out of the whole 80 is going to be nitrogen, and then the percentage is 35%. And now for that 50 kilogram bag, if you work in kilograms, your answer is going to be in kilograms as well. Now we are going to look at empirical and molecular formulae. If we have testosterone, the male sex hormone, that contains carbon, hydrogen, and oxygen. And it consists of, and there they give us percentages. Now remember, a percentage is in 100 grams. Now when we want a formula, we want to write something like this final answer, C19H20O2. We can't write commas down there, we can't write percentages, and this is mass percentage, and that is particles or mole ratio. So we need to go from mass to moles first. So first off, we're going to use our equation N equals M over M, and we're going to divide that, and we're going to say in 100 grams, that percentage means that I've got 79,12 grams of carbon in every 100 grams. So let's say we've got 100 grams. Those are the masses of the different compounds. So we're going to divide them by their molar mass. Now important, we're just going to use 1. You're not going to use 2 for H2. It may be that there's only 1 hydrogen. Remember, in H2O, we only have 1 O. And then that gives you the number of moles. And now that we're in moles, we can have them as a ratio. Right, so in mass, you cannot have the mass ratio, otherwise you'll have to write the grams down there. This is particles or moles, that is true. And then to get them into the smallest possible ratio, we're going to divide by the smallest value over there. And for the 3, that will be the 0,693, divide by the smallest one, and then you get numbers there. Now just be very careful. You can't throw too much away or add too much. You can't round 9,51 to 9, or you can't round that to 10. That's adding too much, right? So if you end with a comma 5, then we're going to multiply by 2 because it's too much to round up or down. So now multiplying by 2 is going to give you that whole, and that is the ratio, and that is my empirical formula. That is the smallest ratio. Now remember, this is always just going to give you the empirical formula. Now let's look at the first example. In that first example, we're going to look at molecular formula as well. Now they tell you an unknown compound X is used in the production of plastic polymers. X contains only hydrogen and carbon. So immediately I know the ratios I'm going to work with is for carbon and hydrogen. And they tell you that 85.7% is carbon. So let's assume we've got 100 grams of compound X. That will mean I've got 85.7 grams of carbon. So let's first convert that to moles. So 85.7 divided by 12, I'm ending up with 7.14 moles of carbon. And now I need the hydrogen as well. Now the hydrogen is the rest of 100. So for the mass of hydrogen, that would be 100 minus that 85.7. So then we end up with 14.30. Now we've got moles and we can put that into our ratio. So C to H is in the ratio 7.14 to 14.30. To get that into whole numbers, we're going to divide by the smallest one, which is now 7.14. And once we divide by 7.14, we are ending up with a ratio of 1 to 2. And then it's going to tell us that our empirical formula is CH2. But we are not finished. In this one, they tell us that the molar mass of X is 28 grams per mole. And now we have to determine the molecular formula. So the whole mass of the compound should be 28. Let's first see what is the molar mass of CH2. Now for CH2, if you work that out, that's only 14 grams per mole. We are supposed to have 28. So let's say 28 divided by 14. Okay, I need to double everything because the mass needs to double. And then you end up with your molecular formula being C2H4. This was the final of our videos on mole calculations for grade 11s.